Hey, what's going on, folks? It's Mike here, and welcome back to my Modern C++ series. In today's episode, we're going to continue our discussion with ranges, so make sure you check out the previous episodes if you're not familiar with what the range is. But this time, we're going to specifically talk about range views and range adapters. Okay, so let's go ahead to some slides here, and then we'll go ahead and practice in a moment. So we're going to be talking about this namespace here, the standard ranges views namespace here. Okay, and I'll go ahead and visit this on CPP reference here, but what is this? What is the purpose of this here? So we've looked at some ranges. We've looked at ranges sort, for instance, if you haven't seen that previous video. And we've seen some of these algorithms here. Now, the real power with ranges, in my opinion, or what makes them really nice, is that they're very, very composable. Okay, so we've got these new things that we call views and adapters. Okay, so we have these range adapters, which turn ranges into views. And what are range views in this standard ranges views namespace? Well, they're basically a lazy, or at least for most of these algorithms, a lazy way to access elements in a range. So what does this mean? They're really easy to work with. They're cheap if there's any copying that's being done at all. Usually there's not. And generally what this means is when we have a lazy data structure, we're just looking at one element at a time in a container or that actual range. So we lazily evaluate one thing at a time as we need it versus doing the whole entire collection right up front. Okay, I'll go ahead and explain here. And again, there is some precision, I suppose, needed here with these types of slides here, meaning, the type of copy, we're usually not copying elements with our ranges unless we're explicitly doing that, which I'll show at the very end here. But generally speaking, views are cheap to work with. Okay, so let me just get that point across. So again, if you haven't heard these terms, eager versus lazy evaluation, the top example on the top right, the basic idea is when we sort something, we say, well, just sort it. Just eagerly sort this algorithm, right away. I mean, we're sort of doing this in both cases where we just say, put in the data and sort it. Run whatever algorithm that you need to. But the idea with something that's more lazily executed, we're going to start seeing this syntax, and you're going to start seeing this standard views here. So ranges, what I mean when they can be executed lazily, that means if there's any copy and assignment taking place, it's a constant time operation for whatever the cost of that copy is. We can have infinite ranges because I can keep adding data onto this collection, for instance, shown here, vector v4, and I'm only at any given time looking at one element because I'm just lazily evaluating it. So if I'm constantly pushing back to this vector, I can, keep running this view because it's only looking at one spot in memory at any given time here. And we're going to introduce a little bit of a new syntax here, the pipe operator here, which does the composition. So this is sort of a functional style here. Again, if you've seen my D language videos, you've seen this with just the dot operator and chaining things together with universal or uniform function call syntax. We've got that same idea here now in C++, sort of. I mean, this idea of chaining things. And maybe you've seen this in like a builder pattern or something, but this idea of saying, hey, let me look at something that's a range. And again, containers are ranges here, so v4. And then I'm going to pipe or just do this view here with a filter and just return the elements that are greater than 5. Okay, so that's the basic idea here. Okay, so we'll take a look at, or maybe code this example up. This is a nice one to get started with. And again, the power, as you'll see in this video and later ones, so make sure to check out whatever else comes after this video, is the ability to say, okay, I don't have to, I can chain one thing, or I can chain two things, or three, or really as many as I want. So in this example, I'm doing this within a range-based view here, so that's the idea here. Okay, so in this case, I'm doing two filters together, running these two views. But again, the cost that I'm paying when I'm looking at these strings here, Mike, Bob, Miguel, Marissa, Mary, I'm only evaluating them one at a time in this for loop. So here's my range-based for loop here. I have this element, and then I'll look at strings, my collection of strings, and then I'll filter and just say, hey, Mike, does it start with M? I don't care about Bob, Miguel, Marissa, etc. I'm just looking at Mike here the first time through this loop. And then I'll also look and say, hey, is that longer than 4 characters? It's not, so just toss it out, okay, and move on to the next thing. Okay, and then look at my next element. Bob also doesn't pass Miguel. That's part of my strings here. It starts with M, and it's longer than 4 characters. Okay, now start processing things. Okay, so that's the sort of advantage of the lazy evaluation, right? We're tossing out pieces of the data before we even process them. And what this does often is it cleans up our code, so I don't need to have a bunch of if conditional statements in my actual body of the loop that are filtering these things out, right? My predicates, so to speak, the tests that I'm running is literally these functions here that I can use this filter. And it's very clear, in my opinion, to read this. Strings, filter, things that start with M, strings, get me a view, filter, and things that are longer than 4. Okay, so that's the idea here. So again, in this test, or rather this example, again, you can think about how this is just a nice syntax. And, if you want, as a little exercise, you can actually think about how many times does this actual loop run, or how many functions or things are actually evaluated, meaning these other functions. You could step through this in GDB to find out for sure. Okay, so now the last thing that I'll mention here is ranges 2 here. Basically, sometimes you do want to actually save the collection. Okay, so when I'm doing this type of thing, these views and filter, I'm operating on the actual strings here. If I were to change them or whatever in this loop here. And sometimes we have to be a little bit careful if we're using auto ampersand or auto double ampersand, right, if we're making a modification there. But anyways, if I want to actually save the view, so to speak, or what happened after these operations of filter, I can use ranges 2. Okay, and you'll see that example here. I'll make sure to do this example as well in code. But basically that collects things. It's kind of similar to back inserter, if you saw when we did that with our iterator examples, in that I'm like, that's sort of like my output iterator, so to speak. I'm saying, hey, where am I writing to? Okay, write this out to some vector. Okay, and that's clearly what we can see on the left-hand side here. Okay, so with that, I think that's enough little examples for us. We can go ahead and just write something. And I'll go ahead and keep CPP reference open here. Let's go ahead and look at the ranges library. And let's see here, we should look at specifically the range adapters, which you can also get to through the front page here, range adapters here. So again, all range adapter does is turn a range into a view, and then we can use those particular views for us, okay? Now let's look at some of these. Let's see here, where are we? We're in ranges. Yeah, let's go into the range adapters towards the bottom here, or about a quarter of the page through. And let's go ahead and look at filter here. Okay, we'll just go ahead and do that as an example. Let's go ahead and create a vector v 1 3 5 7 9 11. Let's not make these sorted, just in case we want to do something else with them later. And let's just go ahead and print this out. Now I did want to mention this because if you watch all these videos, then you saw on the other one, I was trying to just print out the range here, and I said, this isn't working. Well, since then, I have upgraded my G++ compiler to version 16. I will have a video on that at some point if you want to see how to do that. 16 is not released, but if you install GCC 15 or later, I think this will work, and maybe the Clang ones do, where you can just print out the container. So that's some new support for print. I don't have to mess around with writing a function to do this, or loops or anything. It's just kind of nice. So anyways, that's just a little note on that, but it looks like our little program is working. Again, I'm making sure this is at least 20 I think I need, but I need 23 for print. So that's why we're compiling with that. But anyways, let's go ahead and see this filter here. So again, one of the things that you'll notice is the syntax. I mean, there is quite a bit of syntax here. Ranges, : views, and so on. So you can do things like, let's see, using, I don't know, ranges view or something like that. Ranges, views, right? Something like this. Let's make sure that that compiles. Let's see if I messed that up here. Oh, yeah, I did, of course. Namespace. But there's different ways that you can, again, shorten these things up here. So, if you'd prefer to do that, you can. I'm going to type out the whole thing most of the time in this video. But I just want to make that as a remember your other C++ tools here, okay? Oftentimes I sort of teach these things in isolation, but we don't want to forget all of our other tools that we have. So if you don't want to type out this whole long thing because it's annoying, that's fine. And you can come up with your syntax that you prefer for that. Some people like using RNG or whatever. So anyways, let's just go ahead and see how to do this. I'm just interested in printing out stuff for now. And I want to do a filter here. Ranges, views, filter. And what does a filter take? Let's go ahead and scroll out just a little bit here. Let's see. It looks like primarily the thing that it takes here is just some predicate. Okay. Now, again, there's a lot going on when we see these in C++, modern C++, right? We've got our template here that says, okay, this needs to be some sort of input range, which is kind of one of the lower powered ranges. So most things are input ranges, let's say. And then we have some predicate, and this requires for our view that I guess we have an object, and that this thing is itself a view here, okay? So I don't have to think too much about that, but again, I just want to point out that these concepts show up. You can watch my concept videos if that's totally unfamiliar. But anyways, this is sort of the interface for these. So the actual thing we really care about is down here. The filter function here, which would take in a range and the predicate, or just the predicate if we're chaining these together. That's sort of the purpose of having these two versions here. And again, you'll notice the ranges are passed with perfect forwarding. So again, watch my perfect forwarding video if you haven't, to get some understanding of what that is, if this is the first time you've seen double ampersands. But that's the idea there. Okay, so now that we have a few of those ideas here, again, this ranges filter in filter view, I suppose, represent a view of the underlying sequence. Let's go ahead and scroll over with only the elements that satisfy the predicate. Okay, so again, I'm going to add some predicate function here that it satisfies here, and that's the idea. So what will I do? I'll put in parentheses something like this. I'm going to space it out just a little bit so it's clear, and then we could clean this up here. But let's take in some element, whatever it is here. And all I'm going to do is write a function. Let's return if the element is greater than 5. Yeah, let's do 5 here. That's reasonable enough. And that's the idea here. Okay, and then I'll close up my for loop. Okay. Okay, so hopefully that makes sense. Let's go ahead and compile this. Let's close our scope here. See if this compiles. It says, okay, ranges. Let's see if I spelled everything right. New views. Filter is not a member of standard ranges views. Oops, let's see here. I think they might have, actually I might have misread this. I think it's just a little bit shorter or something like that. Standard views filter. Hey, what did I do here? Oh, you know what I did? Let's go ahead and, before we get a header start, let's leave it as is here. Let's actually include the ranges header here. Let's see if that fixes up some of these things here. Okay, good. I'm not going totally crazy. That's going to build. Excellent. Okay, so what did this do here? Well, we've printed out our original vector here. Our code compiles, which is good. So let's just go ahead and kind of sketch this out here. Let's do the original. I'll do a print line, so it's nice there. And then let's just do a print here. And let's just print out our elements here. Let's just go ahead and print out whatever the element is. We'll use our format specifiers. Let's just go ahead and put a space in between them and a comma, something like that here. And then I'll come down here and just put a print line. Okay, so let's see what this does. If I compile and run it, we should see fewer things in our view, but only the things that are greater than 5, okay? Which is what our predicate does here for us, okay? So again, that's a really nice syntax, and we get to see the pipe here, okay? So I would argue that this is, well, whether or not you think it's nice might be subjective, but this is a nice, I mean, it's clear that we can sort of pile these on top of each other, so to speak, and probably a better way to write this ultimately would be to, let's get this out here, and let's just put this as a function greater than 5, greater than 5, there we go. And then I could just pass into my filter greater than 5, okay? And I can close this up a little bit. And now it's reading a bit more clear. So something like this, however you want to indent it is fine here. I'll make this just a little bit bigger here. Let's just put it on this line. Okay, so you get the idea. And I can close this up here. There we go. Now it's a nice, concise program, but does the same thing. Oh, what did I do here? I forgot my semicolon and my lambda function. A few mistakes this episode, but that's okay. But again, you can see the point here, it does the same thing. So that's pretty nice. And again, from a code gen quality standpoint, I think these lambdas tend to get inlined anyways, or possibly could get inlined maybe in the future if that optimization doesn't exist. So that's why I tend to write them like this, but this could be a free function as well if you think you're going to use it all over the place for whatever reason here. Okay, so that's the idea here. Okay, so that's the first one. Let's go ahead and write another example here. Let's go ahead and do it. Let's go ahead and move this note here. And I'll just comment this as example 1. And let's actually use some of our C++ tools here. Okay, so let's just go ahead and show this. Standard, ranges, views. I'm going to get rid of all of this here. RV filter, something like that. Let's make sure it works. Now I've declared this function twice. All right, there will be some mistakes in this video. That's okay. Well, meaning, well, no mistakes, but not every first try will work. But anyways, you get the point here that we can shorten stuff up if that's annoying for whatever reason. But I want to do a little bit of a different example here. Let's go ahead and do that strings example. Let's create a vector of string. So you need to make sure that I include our string header. Let's jump back to where we were. Oh, I guess 20. And let's just call this strings and something like, let's see here, Mike, Bob, Joel, Igor. Yeah, you get the point here. And let's just write another little test function here. And just to show how these compose. So greater than, let's say 3. Let's say for whatever the element is. And, you know, we're treating these as strings here. So let's say the string length is greater than 3. And we're going to run this on strings with our lambda function here. Greater than 3. All right, let's see what happens here. Line 4. All right. Let's see here. What did I do here now? Ooh, I bet this is just a size versus length thing. For whatever reason, let's see here. Oh, I did a few things here. Let's put the parentheses here. Okay, there we go. Mike, Joel, Igor, and Bob. Sorry, you're out. Okay. So that's just one. Let's go ahead and add another. Let's say starts with, you know, whatever. Starts with M. And you could parameterize this. You could do whatever, you know, thing you want here. And then let's just return if the 0th character, or let's just do, you know, at, again, remembering some of our stuff in C++, equals M. And we'll make it capital M. And we'll add in, just make it a little bit more interesting, Mary, who should also show up, who is longer than 3 characters long, and starts with M here. And this is where we want to start composing things. RV filter starts with M. Okay, so that's the idea, and that's how maybe I would indent this one. So let's go ahead and run that, and we should see Mike and Mary here. Perfect. So hopefully that makes sense on the composition. I could do as many of these as I want here. It's probably even worth just stepping through this just to kind of see what's going on. Let's pop in GDB here. If you're not familiar with GDB, I have resources on learning that here. But it's always worth giving a run here. So let's go ahead and start. Right, and let's advance here to line 24 where our loop starts. And I'll move out of the way here just for a second so you can see what's going on here. But let's go ahead and just step what's going on here. Now, this is going to be kind of interesting because we're in the ranges library somewhere here. Let's see if this is useful at all for us to try, sort of count our operations here. Actually, let's just do next here. Let me get out of here. Okay, value returned 2. I mean, this is kind of interesting. I got this. Value returned is Mike when I'm looking at this here. Okay. So let me kind of go next here. Okay, now I'm in my print statement. Next. Okay, and that should have some output here. Let's go ahead and do next. Okay, so if I just do next as far as if I'm running through this, right, it'll run through. And we did see that it was Mary here, okay? That happened fast. I dove deep into the GDB stuff, but let me just go ahead and show you, again, the point of this exercise one more time here. So I'm going to start GDB from the beginning. I'm going to advance to line 24 just so we can ignore our first little exercise, all that stuff. And let's just do next. And this time I'm not going to clear the screen here. I'm going to do next, next, next. Okay, Mike, Mary. Now, again, how many times did that loop run through? Did I hit enter 10 times? No, I don't think so. Right. So again, if we fail early, we return early, so to speak, when we're looking at some piece of data. So again, just keep that in mind with how the ranges are working. They're supposed to be efficient. That's the whole purpose of this exercise, and you can kind of see a little bit of that. Now, diving into the ranges, since they're heavily templated, that could be a little bit messy. You can always add more power to GDB to make that a little bit of a better experience, but anyways, that's the idea here. Okay. Let's go ahead and do one more look at things here. Let's do ranges 2. Here we are. Ranges 2. So this is the thing that I said was interesting. Basically, again, a range, I mean, it's right in the syntax here. It's a view, right? So if you use string view or span, these types of things, which are, nice tools, that's what we have here. And this is fine if we're just like iterating through some data. Maybe we change some data. Again, you got to think about if this is like ampersand or not ampersand or double ampersand, etc. But if I otherwise want to keep this collection for whatever reason, let's go ahead and do that. Okay, so let's go ahead and this time, well, let's set up here, and basically I'm just gonna copy this bit here, or part of this bit, and basically just gonna say, hey, I want my new standard, or maybe even we could do this here, decal type of strings. Let's say filtered strings equals, let's get rid of elements. So it is whatever strings is, and then I'm going to filter it here. And again, I'm being a little bit generous with my spaces here. In fact, maybe a little bit too generous. Some folks might not like this. Let's do this here. Let's move strings up here. So something like this here, right? I've got strings filtered, and then I want to do ranges 2 here. Okay, RB 2. Let's see what namespace that's in. Make sure I try to get this on the first time. So standard ranges 2. Let's just type it out here. Standard ranges 2. What are we converting it to? Let's see if this works. Decal type of strings, right? Whatever that is here. Okay. Now, if you're uncomfortable with this, hopefully it's just going to pick up vector of standard string, right? Because that's what we want here, right? We want it to match this type. This is basically, when I see ranges 2, I'm basically just think of this like an output iterator. It's saying, hey, do this computation on this stuff. Still doing it lazily, but actually save the result somewhere, okay, in this data structure. And then, ranges 2, we'll have to look at the notes, but maybe it's using the string append function or push back if you had a vector, which in this case we have a vector. So that's probably what it's doing here. So first, let's just see if it compiles before we even run it here. Let's see if I messed up any syntax here. Maybe off by 1 parenthesis here. Standard vector of string. And this is a function call, so there we go. Let's see, let's get rid of that I there. There we are. Okay, so that should be looking good here. So I think this should compile. Oops, let's see, what did I mess up now here? Standard ranges 2. And this is, actually I'm glad I didn't, well, maybe we'll mess around with this a little bit here. Here, let's go. Let's see, I have my cheat sheet there, but let's look at the documentation. For standard ranges 2, let's see here. Okay, so we got a lot of Actually, this is a nice one here. It looks scary, but again, we don't want to be scared by documentation. It's telling us, it's trying to tell us the truth here. Let's see, this is exposition only, but I mean, just looking at some of these here, it's kind of telling us what ranges 2 is doing. It's saying, hey, you can use this thing to convert the range to some actual data type, some actual collection. But it needs to have these things here: in place, back, push back, in place, insert. So you need to define these sort of functions here, right? This is the concept stuff that we've talked about, right? So if you have a container or whatever here, or I imagine there might even be one for an output iterator, or maybe eventually there would. So anyways, let's see if we can find like a nice concise description of this here. Let's see here. Let's see. I would say, I mean, basically here, constructs an object of the deduced type from the elements of R. So that solves one part of the puzzle, right? I don't need to do standard vector of string. It can deduce the type here. So I can actually just get away with vector here, which is nice. And I'll put my parentheses. I think this is the one that'll compile. So, I mean, this is really taking advantage of some of the modern C++ stuff. So great, that one compiles. A vector has push back and place back and search, those functions here. Let's see if there's anything else we can say. Constructs an object of type C, that's the container type, from the elements of R in the following, okay? And then these are all the sort of rules here, but that's the basic idea. We're getting an actual new object here, okay, that's allocated. So I think that kind of gets the point here. And then what I can do here is, let's do a print line of, again, the filtered strings. And let's go ahead and run this and print it out here. Okay, so again, what's our example showing us from the source code? Okay, we've got our original example here. That's the first part. We got the second part here, which is just the range-based for loop, which is like, yeah, maybe I just want to do this once. Maybe this is an algorithm. Maybe whatever is in strings is constantly changing, like in an infinite loop or something. Like this is my list of active users on my forum, active people on my airline passenger system, active users in a game lobby or something. So you would just have a for loop that kind of goes over and says, yeah, just process these strings every time in my loop. I don't, you know, I just need a view of them and to do some operation, which in this case is just to print them out. Versus this version here would be, and this is example 3, for when you want to save the results. Okay, so standard ranges 2 saves the result sort of like a output iterator. Okay, when you learned about iterators. So that's the example there, okay? Example 2, just to again be clear about this, let's kind of put some of these comments more in line with what I'm speaking to. But example 2 is more the example when you're constantly processing data over and over again. Example, a game loop or, you know, real-time system where you don't need to store the results, just process, you know, that frame or something, that second, that instance where you need the data. Okay, so that's the purpose of these two. And then otherwise we learned about this nice pipe syntax here, which makes things a little bit, you know, the operator pipe, I suppose, has been overloaded. But you can see how these ranges compose. And most of the ranges, let's see if we go back to the view here and just see if we can make any observation about their return type, just so we can see. Let's see, I gotta dig through this just a little bit. Yeah, most of them just return. The return type you'll see is just another view, and that's how they can kind of compose. So if you've learned about things like the builder pattern and so on, that's the idea. So anyways, folks, that's the idea here with ranges. I'll go ahead and just show the code one more time. Here's basically the whole thing. Of course, don't forget to include your headers. Yeah, that should get you started, and hopefully you understand something or have an idea, maybe some intuition about their lazy evaluation, and then when you want to save the results, you can just remember ranges too. And I think going forward, we'll play around with some more, different examples or composing things, or maybe try to do something fun. If you have ideas about that, feel free to let me know. If there are particular ranges algorithms that you want to use. I mean, we went through most all of the ones in the STL algorithms prior to ranges. And again, these ones work very, very similar. So anyways, that's the idea. And as always, feel free to check out courses.mshaw.io. Let's go ahead and find the C++ lessons, which you probably care about if you want to track your progress and make sure you've watched those other range videos. So there you have it, folks. Thanks for your time and attention. I hope you enjoyed this lesson, maybe learned a few new things, or otherwise how to use ranges in general with an example. Hopefully that was helpful, and I'll look forward to seeing you in the next one.